Question number 5. If y equals to sin x over x, show that x d2y by dx squared plus 2 dy dx plus xy equals to 0. You can always pause the video, answer the question, and then look into my suggestions. Now this question could be very complicated, so what we'll try to do here is, as we move along, we'll find each term, write them on the right hand side, and then add them up, right? So let's begin with the given function, which is y equals to sin x over x. Now from here, we can definitely get that x into y is sin x. So first thing which I get here is what xy is, right? So let me write here that xy is equal to sin x. So right, so we have one term with us, which is the third term. Does it make sense to you? Now let's move on. Find the derivative. First derivative, right? So y dash is equal to denominator square, derivative of sin x times x, so I could write this as x cos x, minus derivative of x is 1, so we get sin x. So that is the first derivative, which I could also write here as cos x over x minus sin x over x squared. Correct. So on the right side, I will write what is 2 times the second derivative, right? So let me write here what is 2 times dy dx. So 2 times dy dx is 2 cos x over x minus 2 sin x over x squared, correct? Now let's find this third derivative now. So the second derivative. So differentiating the first term, we get x squared in the denominator. Derivative of cos x is minus sin x times x, so I get minus x sin x. Minus derivative of x is 1 cos x. So that's the derivative of the first term. Next term, let's put minus here. Okay, so that gives you square of square means to the power of 4. Now, so we get x squared for sure. Derivative of sin x is cos x. So x squared cos x minus 2x sin x. Correct? So which is, let's simplify this. So we'll just write each term separately. So we get the first term as minus sin x over x. The second term here is minus cos x over x squared. Then we have minus cos x over x squared. That 2 powers cancel. Minus and minus becomes plus, and we have 2x cube is left here, right? So x cube is left here. So we have 2 sin x over x cube. So that's our third term. We need to find x times d2y over dx squared, correct? So we'll just multiply all this by x. So the first term will become minus sin x, correct? Second term will become minus cos x. Now here we have 2 of these, right? So I am writing 2 here over x, since we are multiplying the 2 terms, right? So I just added these 2 to give us that number 2 here. Is it okay? Then we have the third term, which is 2 sin x over x cubed. When you multiply by x, we get x squared here. So we get plus 2 sin x over x squared. Perfect. Now, we need to add the 3. So we have to add these 3 terms. This is our third term, second term, and the first term. So if you add these 3, what do you get? That is what we're trying to figure out. So now we're doing the whole thing, adding all 3. So when you add them, you can see how they cancel, right? So we have sin x cancels with minus sin x, correct? plus 2 cos x over x, let's use different things, cancels. And also, we have the third term, which is minus 2 sin x over x squared, which cancels with this, and so we get 0. Correct? So that is how you show it, right? So I hope this process is clear, right? So go through it once again. So hence proved. Correct? So I have very limited space to work with you, but I have explained you how to do it. I hope it makes sense. Question number 6. Determine the equation of the normal to the curve square root 2 sine x plus y equals to 0 at 0. So this is a coordinate point, right? So let me use the coordinate point. At this point, expressed in standard form, the equation of line, correct? So we are given the function which is square root 2 sine of x plus y equals to 0. Now let's differentiate with respect to x on both the sides, correct? So what do we get? We get here derivative of sine x is cos x, so we get square root of 2 cos of x plus y times derivative of inside function, which is 1 plus dy dx, right? 1 plus dy dx. Now this is important part, equals to 0. So that is how you actually get your derivative. Now from here, we can isolate this and find the value of the derivative, right? So now this function could be 0. Now we want to find what the derivative is at 0. So we can now write at 0 pi by 4, what is the derivative, right? So we'll just substitute 0 for x and pi by 4 for y. So we get square root of 2 cos of 0 plus pi by 4. And here we have 1 plus dy dx. So we find the derivative from here. This has to be equal to 0. Okay. So in this equation, we get square root 2. Cos of pi by 4 is 1 over square root 2. And that times 1 plus dy dx equals to 0. And this is 1, right? So we get 1 plus dy dx equals to 0. Or the derivative dy dx is equal to minus 1. Correct? So we get the derivative at x equals to 0. Correct? So that is the derivative. We can say slope at x equals to 0. Now what do we need to find? We need to find normal, right? So slope of normal will be what? So slope of normal will be, let's call m perpendicular, will be negative reciprocal. So it is going to be positive 1. And we know that the point here is 0 pi by 4, correct? So we need to write equation standard form. So we can write y minus y1 equals to m times x minus x1. Correct? Slope of the normal is 1, and we have y minus y1 is pi by 4 equals to 1 times x minus x1 is 0. So that is what we get. So we can now take all these terms to the right side and write our equation as x minus y plus pi by 4 equals to 0. So that becomes the equation of normal in standard form. Is that clear to you? So that is how we are going to do it. Now let's move on and take question number 7. Question number 7. An observer watches a rocket launch from a distance of 4 kilometers. The angle of elevation theta is increasing at pi by 40 radians per second at the instant when theta is pi by 4. How fast is the rocket climbing at that instance? So let's try to sketch and then we'll solve this example. Okay, so let's say that is the situation. So the observer is at this point, let's call this as O, and that's the angle theta, where the rocket is going upwards. Let's call this distance as y. The fixed distance of point A from O is 4 kilometers. Correct? Now, the angle of elevation theta is increasing at pi by 40. So we are given pi by 40 radians per second. Now that means what? That means it is d theta dt. Is that clear to you? Now this is very important to understand. At times from the units you can find what you are working with, right? At instance when theta is pi by 4. This is at theta equals to pi by 4. Does it make sense to you? So that is what this statement means. How fast is the rocket climbing at this instance? So let y be the height. So we really want to find what is dy dt when theta equals to pi by 4. So this is what we need to figure out. So I hope it is absolutely clear. Now, in this scenario, we can always relate with tan theta. Okay, so y is, we can say tan theta equals to, let's rewrite. So we have tan theta equals to y over 4, or y is equals to 4 times tan theta. So that is the relation. Finding derivative with respect to time. So we'll differentiate this with respect to time. So let me take this all on the right side and then we'll do. So we have the function y equals to 4 tan theta. And now let's differentiate it with respect to time. So differentiate with respect to time, right? So we get dy dt, right? So that is what we need. So we get dy dt equals to 4. Now derivative of tan theta will be secant square theta d theta dt, since we are differentiating with respect to time. And now we can find what happens at theta equals to pi by 4. So we have dy dt at theta equals to pi by 4. Substituting the value, we get 4 secant square pi by 4, right? Times d theta dt is given to us as pi by 40. Correct? So that is the value. Now, secant pi by 4 is 1 over square root 2, right? So basically, we know this triangle. So square root 2, that is pi by 4, correct? So this value itself is just square root 2. So we get 4 over 40 times pi, and this value is square root 2 whole square, correct? Now you can simplify this to get your answer. So that gives you the answer as pi 4 goes 10 times, and this is also 4, right? So we get 4 over 10, or I mean 2 over 10, or 1 over 5 pi, correct? Square root 2 square is 2, so we get 2 over 10, or 1 over 5 pi. So that becomes your rate of change. So our answer here is, how fast is the rocket climbing? So rocket is climbing at the rate of, pi by 5, right? We'll say kilometers per second. So because the units will be kilometers per second, so distance and time at theta equals to pi by 4. Does it make sense to you? So that is how you're going to answer this question. I hope the concept is absolutely clear. Perfect. Now let's take the next application question. Question number 8. The depth of water D in meters of a seaside pier can be modeled by the function d of t equals to 3 over 2. So let's write down the function here. D of t equals to 3 over 2 cos of pi by 6t, where t is time in hours. So meters and hours. Determine the rate of change of depth of water with respect to time at 3 hours. So we want to find the rate of change of depth with time when t equals to 3. Correct? So that is what we need to find. So okay, so let's differentiate this with respect to time. So we get derivative of this as 3 by 2. Cos derivative is minus sine. So let me write minus here. Sine pi by 6t, and inside function derivative is pi by 6. Correct? So let's simplify this. So we have 3 goes 2 times. So we have minus sine pi by 6t, and we are cancelling. Let me just cancel this. So 3 goes 2 times here. So we get the constant as pi over 4. So times pi over 4. Okay? So that becomes our equation. Now we can find the derivative, correct? At this at t equals to 3. T equals to 3. So just substitute 3 here. So we get minus pi by 4 sine 3 pi by 6, which is minus pi by 4. Now sine pi by 2. Right? Sine pi by 2 is 1, as you know. So we get minus pi by 4 as our answer. So the answer here is minus pi by 4 meters per hour. Now units are very important in these examples, correct? Let's move on and take the last question here, which is question number 9. Question number 9. A particle moves along a line so that at time t in minutes, its position is sine of t, s of t, is equals to 8 sine 2t. For what exact value of t does the particle change direction in this interval? So we are working in the interval 0 to pi, and we want to find change in direction. That really means that we want velocity to change, right? So we'll find velocity. So as soon as the velocity changes, we know the direction has changed. So let's find velocity is equal to 0, and then we'll be able to figure out when the direction changes. Correct? So velocity of this function is derivative of displacement. So that gives you 8 cos 2t times 2, right? So which is same as 16 cos 2t, which is the velocity. Now to find the critical number, let's equate this velocity to 0. So we get 16 cos 2t equals to 0. Now when is this equal to 0? Well, cos is 0 at, within this interval, it will be 0 at pi by 2, correct? So we can substitute pi by 2 here and get our answer, right? So as you know, this function will be 0 for 2t equals to pi by 2. Correct? So that implies that t equals to pi by 4. So that is our answer, correct? Now, so at pi by 4, let's substitute this value. So we know the first answer, which is at pi by 4. Now it's kind of important to understand that this interval is given to us for time, right? So it says change in direction in the interval 0 to pi. Now if you look into the cosine function, let's just extend this a bit. Okay, so it will have actually 2 zeros here, one at pi by 2. Then we have at 3 pi by 2. That is also 0. Now if I divide by 2, we get this as 3 pi by 4, which is actually less than pi by 2. So we could also take 2t equals to 3 pi by 2, which implies that t equals to 3 pi by 4. So we actually get 2 points here where the direction is going to change, right? So, so do you understand this part? So those are the turning points. So for what exact value of t does the particle change direction in this interval? So we have two points here. So I'll say here. So the answer here will be at t equals to pi by 4 and t equals to 3 pi by 4. Correct? So every time the velocity becomes 0 in this case, it changes the direction. Perfect? So that is how we could actually find the answer for this part. Now the second part is, what is the particle's maximum velocity in this interval? Now to find the maximum velocity in this interval, we'll actually analyze the first derivative, velocity, right? So let's find the derivative of velocity itself, which is acceleration. So acceleration is the first derivative of velocity. We have the expression here, 16 cos 2t will be minus 32, that is 2 times this. Cos derivative is minus sine, so we get minus 32 sine 2t. Correct? So that becomes the derivative. Now to find the critical numbers, we can equate this to 0, right? Which will be 0 for sine. If you sketch the graph, it's easy to sketch the graph, see and explain, right? So there are 3 zeros. Now when we say t is between 0 and pi, in that case 2t is going to be between 0 and 2 pi. Now that is why I'm taking two different values. You should understand this part, right? So as far as t is concerned, that is my graph. Now we want that sine 2t to be 0. So there are 3 points where sine 2t could be 0, right? So these are the 3 points. Now this is a sine function. This is negative, so it goes in the other direction, correct? So as far as our acceleration goes, let me sketch the acceleration part. Okay. The acceleration part will be kind of like this. This is the acceleration part. Is it okay? Where this point is going to be minus 32 and that is going to be plus 32. So what is the particle's maximum velocity in the interval? The question is straightforward though. So maximum velocity will be, we can find will be at, you can say 16, right? But we have to show and prove it. That's the whole idea. So that's what we are trying to do. So the maximum velocity occurs when the rate of change is from negative to, from positive to negative. Do you see that? So when it changes from positive to negative, then we have the maximum. Correct? Then we have the maximum. Now here, the critical points for time t being 0 will be at, so we have 2t equals to 0, pi and 2 pi. So these are the 3 critical points. So t is equals to 0, pi by 2 and pi. So these are my 3 critical points in this particular case. So let's find the maximum velocity at all the 3. So we have velocity vt as equals to 16 cos 2t, right? So if I substitute 0, pi and 2 pi, in that case, for 0 and 2 pi, we'll get cos t as maximum, right? So we find that the velocity for 0 is equals to velocity for 2 pi, right? And, t equals to 0 and pi, because 0 and pi. In that case, it is equals to 16, correct? At pi by 2, it is negative. So at pi, it will be negative 16. So we get our result here, maximum velocity equals to 16, and the units here are minutes and meters. So meters per minute. Perfect. And that happens at t equals 2. This happens at t equals to 0 and pi. Correct? So that is how you're going to find the solution for the last part. So I hope you find this series interesting and useful. I've taken up one full test paper, 9 questions, for which you are given 75 minutes to solve. Now I hope this explanation helps you to understand and review the whole topic. Feel free to write your comments, share your views, and if you also share with me your test papers, I can provide you with their solutions. Feel free to share my videos with your friends. Thanks for watching and all the best.